It's coming at you with an eye-popping video about math. This time we're talking about volume. This is going to be a three-part series, starting with part 1, the volume formulas, or just the basics. So let's get started because we're going to do the definition of volume and then do 6 examples. Okay, first let's talk about the definition of volume. So the amount of fluid contained in a three-dimensional object. We'll talk about 3 dimensions. Let's talk about fluid. So fluid is referring to anything such as gas or liquid that can go into an object. So like your cup. How much air can your cup hold? How much water or orange juice will your cup hold? Okay, we're going to figure that stuff out mathematically. All right. Let's take a look at the first example. So the first example, this is a rectangular prism. The single hash marks there, or apostrophe, the single apostrophe is feet. So this is saying 11 feet, 6 feet, 3 feet. And the volume of a rectangular prism is length times width times height. 3 dimensions, 1, 2, 3. Now, length times width times height. But it could be width times length times height. It doesn't matter because these are multiplied. So as long as you can identify 3 individual dimensions, you're in good shape. So let's do this. So I have 3 times 6 times 11. I don't know what 3 times 6 times 11 is off the top of my head, so I'm just going to punch this into the calculator. And that's 198. Feet cubed. 3 dimensions, right? So, feet to the 3rd power. Area is feet squared, because it's only 2 dimensions. Okay, next. Let's do a cylinder. So the cylinder has the area of a circle times the height. 2 dimensions times the 3rd dimension. Let's keep that in mind for later. We're going to need that idea. So I have a radius of 4. So this is my radius. And this is my height. I'm going to plug that information right in here. 2 apostrophes, or a pair of apostrophes, is inches. So this is 4 inches, 12 inches. So V equals pi 4 squared times 12. 4 squared, or 4 times 4, is 16 times 12. Now, I don't know what 16 times 12 is. Notice how I'm ignoring the pi for a second there. 12 times 16 is 192. So I'm going to leave this in terms of pi by saying 192 pi. That's the exact answer. Okay, if I wanted to multiply by pi and convert it to a decimal, I could do that. But let's talk about this 3.14 business. 3.14 is not pi. Pi is a very long, okay, infinitely long for that matter, an endless irrational number. So, being irrational, which makes it endless, if you say 3.14, you're just picking a number for pi. Because why isn't it not 3.141 or 3.145926? Why are you stopping at 3.14? Because it's convenient. Well, I'm going to make the argument it's even more convenient if you just leave the symbol pi. And not only is it more convenient, it's more accurate. Because here I had to approximate, I had to round. Okay, I went from that nice number, 192 pi, to this massive irrational number that's never going to end. So I had to round. And I used my approximation signs, or, as they're technically called, double mustache. Okay, next, let's work on a cone. Now, first thing, let's talk about the formula for the volume of a cone. 1/3 pi r squared times height. Well, we just looked at the volume of a cylinder, right? That's just pi r squared times height. It turns out 3 cones makes a cylinder. So here I am using the area here of the circle and multiplying it by the height because the base of a cone is a circle. We're going to need that information later. Now, they gave me the diameter and I need the radius. So the radius is the diameter divided by 2. So since my diameter is 8, I'm dividing that by 2. So my radius is 4. Okay, now I have my radius. I'm going to plug this in. So V equals 1/3 pi 4 squared times 11. 4 squared is 16. So that's 16 times 11. Now, I noticed that 16 is not divisible by 3, and neither is 11 divisible by 3. So that means when I multiply by 1/3, this is not going to come in that evenly. So let's take a look at what we get. 16 times 11. That's 176. 176. 1 plus 7 plus 6 adds to 14. 14 is not divisible by 3. That's a 3 divisibility rule. The total of the numbers need to be divisible by 3 in order for the entire number to divide by 3. So, knowing that, I know that when I multiply this 1/3 by 176, I'm going to end up with 176 over 3. Watch. I'm going to take that and multiply that together. Now, what good is using all this number sense while I do this? Well, it's helping me get the precise answer smoother. I'm thinking through the problem as I work it through. I'm not just smashing this into the calculator and hoping for the best. I'm thinking about what my answer should look like before it comes out. Now here I am again with this nice precise number, but some of you may be required to have a decimal. Honestly, if you're using this information for some reason, such as you need to actually make it, then you may need the decimals, right? So it's not uncalled for to use the decimals, but if we're just dealing with the math itself, then the precise answer is just nicer and more convenient. Okay, next. This is feet cubed. Almost forgot that unit again. Okay. So let's do this one. All right, we're dealing with meters here, and this is a pyramid. This is what's called a rectangular pyramid. So notice that capital B there. So we got V equals 1/3 times capital B times H. Sometimes it's just called big B. So capital B is referring to the area of the base. Area of the base. Okay? And in doing so, I have to find the area of the base first. But let's take a look real quick at what I had to do with the cylinder. The cone, excuse me. Area of the base, right? The area of the circle, then times the height. Now in this case, that smoothed out and kind of rolled pretty nicely. But that's not always the case with these. This guy recommends that you find the area of the base first, then plug it into the formula. So let's do that. The area of the base here is a rectangle. The shape of the base is a rectangle. So the area of a rectangle is length times width. Okay? So 11 times 10. That's 11 meters times 10 meters, which is going to give me 110. And I'm going to just write this here just for fun. It's really not that helpful. Meters squared. Now I'm going to take that 110 and plug it into the area of the base. So now I have V equals 1/3, 110 times 9. because that's the height. Well, look what I got here. 1/3 times 9. That's going to clean up really nicely because 9 is divisible by 3. So I struck gold. I feel that way, right? Because 1/3 times 9, or 9 divided by 3, is 3 times 110. So that's going to give me 330. Now, that's it. And this time, it's meters cubed. Okay, 3-dimensional, 2-dimensional. Just worth comparing. All right, let's take a look at the next one. The next one is a triangle pyramid, and I'm using that example to kind of bring this area of the base business home for you. Area of the base, right? Well, I have a triangle here. Well, the area of a triangle is A equals base times height divided by 2, or 1/2 base times height. I'm going to use the 1/2 base times height because I like fractions. And if you use fractions more often, you will like them too. So, here's some trickiness here. For starters, I have a whole mess of dimensions and measurements, but you got to keep in mind, I only need 3. Okay, so one of these 4 I am not going to use, and that's going to be this one. Because that's the hypotenuse of a triangle. I know that because it's across the right angle. So here's my base and my height. So if I took this and redrew it, I'm going to do that for you. You don't have to do that. It would look something like that. Okay? So there's my height and my base together. So now I have A equals 1/2 4 times 3. So 1/2 4 times 3. Well, here I am again in this nice situation where I have an even number. 1/2 times 4 is 2. So that's 2 times 3, which gives me 6. Now, let's just say you didn't notice that. 4 times 3 is 12. Okay, 4 times 3 is 12. Half of 12 is 6. So you end up in the same place. So now I have this. I'm going to label this again. Right? And now I'm going to plug it in here. So that's meters squared, 6 meters squared for the area of the base. So V equals 1/3 6 times, well, 6. Okay. Because the height happens to be 6. I kind of hate that for this example, but let's please keep in mind that this here is big B, and that's the height. Okay. Well, the same rule that applied here is going to apply here. So 1/3 times 36. 1/3 times 36 is 12. One thing that's nice about math is that once you know the rules and you have control of them, they never change and you can apply them all the time. The hard part about math is knowing all the rules all the time. It can be very difficult. So the answer to this problem is 12 meters cubed. All right, last example. And it is a sphere. The volume of a sphere is 4/3 pi r cubed. They gave me the diameter again. So I have to find the radius. The radius is the diameter divided by 2. So the diameter is 20, divide by 2, and the radius is 10. So now I'm going to plug that in. So V equals 4/3 pi 10 cubed. Okay. My experience tells me, not my intelligence, let's make that clear. My experience tells me that 10 cubed is 1,000. Look, 10 times 10 is 100. And then times 10 again is 1,000. I'm just adding the zeros. So, or piling on the zeros towards the end. So that's going to be 1,000. Pi 1,000. Okay. 1,000 times 4/3. Well, let's do that off to the side here. I'm going to do that with this black marker. 1,000 over 1 times 4/3. If you're wondering why I'm pushing this so hard, it's just because a lot of you guys struggle with numbers. This is how we get past that struggle. We do things like this. And then over time, this gets easier. We multiply fractions across. Now again, with my rule that I applied before, not my rule, it was actually a rule that was proved a long time ago. 4,000, the total of 4000 is not divisible by 3 because it's 4. So that will not reduce. So I have V equals 4,000 over 3 pi. And in this case, it's yards cubed. I almost think you're supposed to have an S there. So the program that wrote this, I don't think put an S there. And then again, if I really want to, if I have to for some reason, and sometimes we do, convert this to a decimal, I can by just using the pi button. Now, if you're stuck without a pi button for whatever reason, and then multiply by 3.14. But as you could see, hope you could see, that not having a pi button isn't a big deal because you just work these out. Okay, then put pi at the end. All right, this is the video, part 1 of the series and volume. I hope you guys found this video helpful.